Okay, on number 3, I took away your coordinate grid. So as we look at number 3, the first thing I would do is I'll make a rough sketch, okay? So what I mean by that is, it doesn't have to be fancy, but just so you can get a kind of a visual of what's going on here. A is at 0, 4, so let's put A in there at 0, 4. So A is right about there. B is at 4, 5, so just a little bit above. There's A, there's B. And C is at 1, 0. So C would be right about there. Make the triangle, and part of the reason why I'm doing that is then I can quickly see the side lengths I'm going to find. I want to find length of AB, I want to find the length of BC, and I want to find the length of AC. So unfortunately in all those, where we're at is using, we're going to have to do Pythagorean theorem or the distance formula. Here, I would go with the distance formula. So it's going to be a little bit of extra work because I don't have a nice coordinate grid to say doing the Pythagorean theorem. So I'm going to work that down below. Okay, I'll do one of these and then the rest of them I'll just kind of do in my head. All right, I'm going to go off to the side here and find AB's length. Again, using my distance formula. All right, clean that up. And I get the square root of 17. Does not simplify down, but square root of 17 is where we're at. All right, for the other ones, BC, go do your distance formula again. I'm going to, again, just kind of do it on my calculator as I'm over here, jot down some information. So BC is what I'm doing, change of 5, change of 3. So that is 25 plus 9, which is 34. So this is going to be the square root of 34. AC is a change of 1, change of 4, another square root of 17. So going through, finding out those, what I end up with is, it wouldn't look like it from my sketch, my picture, but it actually looks like I end up with an isosceles triangle because of those square roots of 17. So that is because AB is congruent to AC. Now it's isosceles. The other thing is going to be is maybe I have a right triangle hiding in there as well. Isosceles can't be right. So it probably, if it happens, it's going to probably happen in A. But what I'm going to do here is just like I did up above. All right, I'm going to go find my slopes. Okay, I want to go find the slopes of those 3 sides. So I'm just going to use my slope formula. So AB, kind of doing this in my head at the same time. AB, its slope, 5 minus 4, change in the y's over the change in the x's. So it looks like I get a fourth. I want to see if there's any relationship that else happens with a fourth. Okay, BC, I'm doing 0 minus 5. 1, 0 minus 5, 1 minus 4 is 3. Negative 1 minus 4 is negative 3. So it looks like I get a positive 5/3. No relationship there. AC. All right, 0 minus 4 is negative 4. 1 minus 0, 0 minus 4, 1 minus 0 is 1. It looks like I get a negative fourth, or negative 4. Well, there it is. AB and AC are going to turn out to be negative reciprocals. Okay, so because of that, I'm going to say it's isosceles, and I'm also going to say it's right. So I took care of the isosceles part, and I'm going to grab the isosceles part and move it down here, and I'm going to complete my explanation. The side's right there, and then the other thing is going to be, it is a right since AB is perpendicular to AC due to negative reciprocal slopes. And I keep asking about the midpoint of AB, 2, 1/2.